Guys, welcome to another episode of Crimes Notes. Today we are going to be talking about transformations of the cube root function, except for this time we're going to be talking about writing the equations. So what we were doing was just trying to figure out what the graph was based on the transformations that were given, but now we're actually going to be trying to figure out the equation from various information that they give us. So again, our topic is writing cube root equations. Throughout the course of the notes today, you'll have about 5 problems or so. We're going to try to write the equations, and you should be able to do that with a minimum of probably 70% accuracy or so. And the main thing that you kind of need to get out of this is, what does a cube root function look like, especially after it's had some transformations and things occur. So first of all, let's review the cube root function. Okay, remember, this is the original graph. So the original graph starts at the bottom, right? It goes and then it turns and it goes towards the top. So it's a positive function. Its inflection point, or the middle of the graph, is at 0, 0. And then the key points that we need to pay attention to are 1, 1 and negative 1, 1. We can write the equation in 2 ways. We can write it as a cube root, or we can write it as x to the 1/3. They are exactly the same thing. We can write it with an f of x in the front, or we can write it with a y in the front, because remember, f of x just means y. The domain was negative infinity to positive infinity. The range, and I'm just going to copy and paste. So the range was also negative infinity to positive infinity. The inflection point, which is what we just talked about, is at 0, 0. And then the key points were negative 1, 1. Whoops, negative 1, negative 1. There we go. And 1, 1. We do have an x-intercept and a y-intercept, which also happen to be the inflection point. So these would both be 0, 0. Remove. I didn't leave myself enough room there. So this is what we need to know, that this is what the shape of the cube root graph looks like. So if all of a sudden my graph starts at the top, goes through 0, 0, and then comes down into quadrant 4, we would know that it has been reflected, and therefore we would know that the a value is negative. So those are the kinds of things that we are looking at. So given the following transformations, we want to write the cube root equation, and we're writing it in vertex form, which is down here in the bottom. So right here, we've got our a, our h, and our k, and those are the values that we have to reflect or to replace. So it says the parent function y equals the cube root of x is reflected over the x-axis, shifted left 2 and down 5. So this, we would have to go back and think about our initial chart where we talked about if the a value is positive or negative, that it reflects. Well, if it's negative, it would reflect over x. So we know that it's going to be negative, but they didn't give us a number. It didn't stretch, it didn't compress, so I can't really put anything. And we could just put a negative, but let's put negative 1 just because it gives us a better sense of what's happening. So then we're looking at our h value. Remember, h means horizontal, right? So that's our left and our right. That's which way we are going. And it's going to the left. But if you remember, everything with h is opposite. So if we were at 0, 0, and we wanted to go to the left, which would be this direction, I think, because I have to go opposite for it to look that way to you, okay? We would typically think that that's going towards negative numbers. But with h, it has to be the opposite. So left would actually mean that we're going a positive 2. Now, I don't really need the positive, but I'm putting it in there so that we can use it in a minute. The last thing is our k value. Remember, that's our vertical. That's our up and down. And in this case, it says the graph was shifted down 5. Well, that's exactly what you think. If you're in the middle and you go down, that goes into negative numbers. So this would be -5. So now what we're going to do is go into our equation and we're going to replace. So this A value was -1. Our H value was +2. So I need to go in here and change not only the H, but also the sign. So that's a +2. And then the same thing with K. That ends up being a -5. And so our equation is the cube root of x plus 2 minus 5. And so if we were to put that into Desmos and graph it, which I'm actually going to do, I'm going to see if it'll work, just so you guys can see what this looks like. Close. All right, let's come over here. So if I put this in, now when I copy it in, notice it gives me this error message. It does not understand this cube root symbol right here. So remember, we're going to erase it and put CBRT, and then underneath it, we need to put x plus 2. And then I'm going to go out here and delete the other x plus 2. So there's our x plus 2 minus 5. So now if I look at the graph, remember how we talked about usually it starts low down here, then comes and goes up like this. So if it does the opposite, if it starts high and then goes low, that it reflected, which is that -1. Then I'm going to go ahead and put in some of the points just so that we can see them. Okay, here's that inflection point, which is -2, -5. Well, that's what we said. It went to the left and then it went down. And so that's what created that -2, -5. Okay, so we did get a correct transformation. Okay. All right. So let's go back to our slides over here. So it says one more, right? Given the following transformations, write the cube root equation. The parent function y equals the cube root of x is compressed by 3/4, translated 4 units to the right, and up 6. So again, we're going to start with our A value. And again, I just happen to be writing them in the right order, but they could tell you that it moves left and up or whatever first, and then that it's compressed. But it says compressed by 3/4, which means our A value is 3/4. It's translated 4 units to the right. So remember, if we're going to the right, generally that would be towards positive numbers, but everything is opposite. So this is going to be a -4. That's how we get it to go to the right. And then up 6 would be a +6. Now again, I'm putting the plus just so that when we go to put it into the equation, we don't forget. So now we're going to go in and we're going to replace. So we said that the A value was 3/4. We said the H value was -4, so I don't have to replace that minus sign. And the K value was +6. And so we would just put that in. So this next one, I want you to try. Okay, use the transformations to write the equation. Use the examples that we've given you and see if you can replace the A, H, and K correctly. All right, so what if they give us the information in a different way? Now notice it says that our transformations say that the new vertex for the cube root parent function is -8, 7, and the key point was shifted to -7, 9. Well, what would be our thought process? If you notice off to the side, it says the original vertex is 0, 0. And it's not really the vertex, it's the inflection point, but we get the idea. The original starting point is 0, 0. Which way would you go to get to -8, 7? Or remember, we could use that our vertex is H, K. So this is opposite H, K. So we could always use that as well. So this should be the opposite of H. So if this is -8, then the opposite of that would be +8. And so if we go in here, this should be a +8. The other point of that is if I was trying to get to -8 and then to 7, I went to the left and then up. Well, left is positive 8, okay? Then 7, that's a little bit easier. We obviously went up, so this is plus 7. So the last thing that we have to try to figure out is the A value. And I've got a little note over here off to the side for that too. For the key point, you want to compare the Y values, okay? So the Y values of the vertex and then the Y value to the key point in order to find the A value. So the Y value of our vertex, or the inflection point, was 7. If I go to the key point and it's -7, so I went up 1, the 7 to 9 is a positive 2. So my A value went up 2, so we would say that this is a positive, a positive 2. Okay, again, all we did was compare the A values. So this was 7, this was 9. So if we go over 1 and then we count, we go up 2. So that makes our A value positive 2. So then we would be ready to go in and replace. So this would be 2. Again, we don't need the plus. The H is supposed to be positive. So we're going to put positive and then 8. And then our K value is positive 7. And so we would put it in that way. So same idea. Now I want you guys to try one on your own. Again, think about your opposite H of K. So we can find H by taking the opposite of the 2. And then K is exactly what's written as part of the inflection point. And then remember, compare the Y values to find the A value. So what did I do to get from -4 to -7? Okay, did I add or did I subtract? And that'll tell you if this is going to be a positive or a negative value when you're plugging them in. All right, lastly, this is writing the cube root function if we're given the graph. The idea is the same. We still want to see what the new inflection point is, and we want to compare the new key point. So we're going to scoot over 1 and see which direction we go. Now, I will say on these graphs, please, please, please be careful on the scale. Notice when you're counting boxes, this says 2. So going up 1 over 1, this is our original function. So starting at 0, 0, over 1, up 1 takes us to this point. So we want to find our new inflection point. So the graph, we need to find that place where it goes and then it kind of comes up and then it comes off so that we can see where that point is. So if I'm tracing the new graph, because we're looking for this purple one, here's where it starts to curve and then it curves again. So this would be our inflection point. So we need to find where that is. So this is 2, this is 4, this is 6. So halfway would be 5. And then this is up 1 and this is up 2. So this point is at 5, 2. So my inflection point is 5, 2. Well, remember, 5, 2, and I guess I should probably type that somewhere. On your slide, there will probably be a random box right here where you can type that in. I'm going to go ahead and put 5, 2. Okay. So now that is the opposite of H. So if that's 5, then this is -5, and then K. So that would be 2. Now I need to find my A value. Well, remember, all I have to do is see what happens when I go over 1. So if I go over 1 and I go up 1, 2, 3, and then I ran into that point. So that means my A value would be 3. Now remember, we're always going to go 1 to the right. So if I go 1 to the right and then I have to go down, that means that my A value would be negative. So now I'm ready to go ahead and go in and replace these. So this is 3. My H value is negative, so I'm just going to put 5. And my K value is already positive, so I'm going to put 2. And this would be the graph that we would get. So here's yours. Remember, this is our original graph. Here's our 0, 0. Here is 1, 1. Here's our -1, -1. So here we're looking at this red graph. Now notice it changed directions. We didn't start low and go high. We started high and we got low. So we should automatically know that that A value is negative. This right here, this is your inflection point. So I want you to use this scale and see if you can figure out what it is. Then use your opposite HK and get your H and K. And then remember, you're going to count to the right one and then count what it takes to get to this point right here to get that A value and then replace it. So other than that, all that's left would be for you, could you explain this to a peer? And then you're going to drag your bar, which is not on there right now, but I'll get that on there, to where you think that you would be at this point in this lesson. So I hope that gets you guys through the basics of transformations. Again, this is just review. We did this with quadratics before. So if you have any questions, make sure that you ask. Otherwise, have a great day, and I will see you next time.